Hello guys, it's your favorite teacher, Godson, and you know what it is. This is Wits Lounge, learning made easy. Okay, now with that said, we are gonna be studying something quite cool today, and that is electrolysis. Before we get into the study, if you haven't subscribed to the channel, please do that. Okay, thanks a lot. Now, electrolysis. When you think about the term electrolysis, something should come to your head, and I guess that is electricity. Yes, in electrolysis, you're going to be dealing with electricity. So, buckle up as we go on in the study. So, you think of electrolysis, you think of electricity. However, it has to do with an energy conversion. And yes, we know that energy can neither be created nor destroyed, it's converted from one form to the other. That's why in your pressing iron, you have electrical energy converted to heat energy. And that's cool. But in this case, we are dealing with a different conversion. And what is that conversion? First of all, before I define it, I would like to help us understand something. You have your phone, and this phone has a battery inside. The energy conversion inside this phone to power this phone is that you plug in your battery. Your battery contains chemicals and they produce chemical energy. This chemical energy, as a result of the chemical reaction, will lead to the production of electricity. So you notice something. In the battery, you have an energy conversion from chemical energy to electrical energy. Electrolysis, on the other hand, is the exact opposite of that process. So if your battery has an energy conversion of chemical energy to electrical, electrolysis is electrical to chemical. Okay, so with that said, let's now put out a proper definition of electrolysis. Electrolysis is defined as the chemical decomposition of a substance which is brought about by passage of electricity through the substance in its liquid state. I take it again. Electrolysis is defined as the chemical decomposition of a substance which is brought about by passage of electricity through the substance in its liquid state. So, what does that mean? You have, for instance, a particular chemical, sodium chloride, and you want to begin electrolysis. For electrolysis to start, you have to pass electricity through this setup, and once electricity gets into the substance, electrolysis begins to occur. But note something, that substance must be in its liquid state. So I take it again, electrolysis is the chemical decomposition of a substance which is brought about by passage of electricity through the substance in its liquid state. So have this in mind. When you think electrolysis, think electricity passed to bring about the chemical decomposition. So a chemical reaction that is brought about by passage of electricity is electrolysis. Having said that, the substance being mentioned in this case is referred to as an electrolyte. I take it again, the substance being mentioned in this case is referred to as an electrolyte. Okay, so having said that, we will be extending this study into other aspects of electrolysis. But before I get into that, I hope you notice something, that whenever electrolysis is going to take place, the substance must be in its liquid state. And how do you make a substance liquid? There are two major ways to make a substance liquid and then produce them as ions. Number one, dissolve them in water to form aqueous solutions. Dissolve them in water to form aqueous solutions. So when I get my sodium chloride and I put it inside water, what happens? It tends to dissociate. We'll talk about that when describing Arrhenius ionic theory. So the first way of making an electrolyte to be liquid is by dissolving it in water so it becomes aqueous. Or you could melt it. When you melt it, it turns into liquid. So have that in mind. To make an electrolyte to become liquid, the two ways are, number one, dissolve it in water to form aqueous solutions, or you melt it so it becomes molten. So that's that on how to make the electrolyte liquid. With that said, we'll briefly get into defining some terms in electrolysis. Some terms, special terms in electrolysis. And I'll be putting out 5 of them. The first one we are going to talk about is electrolyte. So, what is an electrolyte? I think I mentioned that earlier on. Electrolytes are substances which are chemically decomposed by passage of electricity. I take it again. Once you have a substance and you pass electricity through that substance and a chemical reaction is started, that substance is referred to as an electrolyte. So I take it again. An electrolyte is defined as a substance which is chemically decomposed by passage of electricity. Nice, simple. And then you note something about an electrolyte. It must be in its liquid state. It must be in a liquid state. And we have discussed already how to make it liquid. Number one, dissolve in water. Number two, melt it. Now, having said that, electrolytes can actually be classified into three. You have your strong electrolytes, your weak electrolytes, and your non-electrolytes. The classification of electrolytes is specifically dependent on its ability to form ions. We'll talk about that when we get to the mechanism of electrolysis, but have this in mind. Classification of electrolytes is simply dependent on its ability to form ions. What am I trying to say? You tend to dissolve some substances in water and every of the substances or every molecule of that substance dissociates to form ions. That is referred to as a strong electrolyte. What do I mean? Strong electrolytes are those substances or those electrolytes which, when dissolved in water or melted, tend to dissociate completely. They undergo complete ionization. That is to say, every molecule of that substance dissociates. If I have 1,000 molecules of the substance dissolved in water, I'll have 1,000 of those molecules dissociated to form ions. Those guys are referred to as strong electrolytes. You go to the next one. Okay, before we get to the next one, example of strong electrolytes are your strong acids, your strong base, and your salts. Those guys often serve as strong electrolytes. Strong acids, complete ionization. Strong base, complete ionization. Salts, they can dissolve in water to be completely ionized. So have that in mind, that your strong electrolytes are those substances which, when dissolved in water, they dissociate to form ions completely. Every of the molecules dissociate. Strong electrolytes are those substances which undergo complete ionization when they are dissolved in water. Okay, so let's let that slide go on. Now, the next classification is your weak electrolytes. What are weak electrolytes? Weak electrolytes are defined as substances which undergo partial ionization when dissolved in water or melted. So don't undergo complete ionization. Because of that, they are referred to as weak electrolytes. Examples of such electrolytes are water. Water is a weak electrolyte. Your weak acids, your weak base, and all whatnot. So have that in mind. Weak acids, weak base, and water. These are very good examples of your weak electrolytes. And then finally, you have your non-electrolyte. Any substance that cannot produce ions, any substance that cannot produce ions is referred to as a non-electrolyte because it can't decompose when electricity is passed through. The major reason is this: the passage of electricity through an electrolyte is as a result of movement of ions. So if it doesn't produce ions, there will be no passage of electricity, and if electricity is not passed, there will be no chemical decomposition. So have this in mind: a non-electrolyte is a substance that does not produce ions when it is dissolved in water or melted. Okay, so that's the first step. Electrolytes. What did we say is an electrolyte again? An electrolyte is a substance which is chemically decomposed when electricity is passed through it in its liquid state. Okay, moving ahead, we go to the next term. The second term is electrode. So what is an electrode? An electrode is quite easy to understand. First of all, an electrode is a conductor. It is a conductor that allows electricity to and through the electrolyte. It carries electricity to and through the electrolyte. So I take it again. An electrode is that conductor which carries electricity to and through the electrolyte. Okay, so with that said, we have two classifications of your electrodes. Two classifications of electrodes are your anode and your cathode. So, what is an anode and what is a cathode? Before I go further in this, I would like you to remember or note this. The chemical processes or the processes that occur during electrolysis or in an electrolytic cell is quite the opposite of what occurs in a voltaic cell. I take it again. processes that occur in an electrolytic cell is quite the opposite of that occurs in a voltaic cell. Your voltaic cell is your battery. Your electrolytic cell is where electrolysis occur. If you notice, I told you earlier on in the video that the reactions in a battery is the exact opposite of electrolysis. However, oxidation would always occur at the anode and reduction would always occur at the cathode. So, with that said, what is an anode? An anode is an electrode. An anode is an electrode where oxidation occurs, while the cathode is an electrode where reduction occurs. So you could use the term anodic oxidation, cathodic reduction to keep it in head. Somehow you can keep that in your head. So have this in mind: anodic oxidation, cathodic reduction, anodic oxidation, and stuff. Okay, let's scratch that. Move on. So anodic oxidation, cathodic reduction. Whether you are dealing with your voltaic cell, which is your battery, or your electrolytic cell, oxidation always occurs at the anode and reduction occurs at the cathode. Now, electrodes can be positive and they can be negative depending on where they are found. If we are dealing with electrolysis, which we are actually talking about, the electrolytic cell has the anode as the positive electrode. The electrolytic cell, in the electrolytic cell, the anode is the positive electrode, while the cathode is the negative electrode. It becomes the exact opposite when you go to your voltaic cell or your battery. But when we get there, we'll discuss that. But for now, have this in mind. In the electrolytic cell, anode is the positive electrode in which oxidation occurs, while the cathode is the negative electrode in which reduction occurs. So we've noted two major features of the anode of an electrolytic cell. The first feature of the anode of an electrolytic cell is that it is the positive electrode. Secondly, it is where oxidation occurs. The cathode is the negative electrode, and secondly is that the cathode is where reduction occurs. Now, we will be looking into the arrangement of an electrolytic cell, and that will help us get more into the characteristics of the anode and the cathode. What do I mean? What do I mean? This is a setup which represents an electrolytic cell. Let's call this the anode, and let's call this the cathode. And this is the electrolytes. We are not discussing the mechanisms here, but I just want to explain something. Now, if this is the positive terminal and this is the negative terminal, okay, yeah, we have that. Now, the anode in an electrolytic cell is connected to the positive terminal of a battery. And because of the fact that it is connected to the positive terminal of a battery by contact, it is positively charged. So the anode is connected to the positive terminal, and because it's connected to the positive terminal, the anode becomes positively charged. Now, the other thing about the anode is this. When you connect a positive terminal to a metal conductor, you notice that something happens. Unlike charges attract. So the implication is the positive terminal will tend to attract the negative electrons on the surface of the metal. So you have that when the anode is connected to the positive terminal, first of all, it becomes positively charged. Second of all, is that the electrons on the surface are attracted towards it. So that means you notice that electrons tend to leave and go towards the positive terminal of the battery. Now, when you get to do electricity or current electricity in physics, you would find out that the direction of electrons or the direction of the movement of electrons is the exact opposite to the flow of current. That is to say, if electrons are going in a particular direction, current is flowing in the opposite direction. So have this in mind. When electrons are moving towards the left, current is moving towards the right. When electrons are moving upward, current is moving downward. So you get the point. Wherever an electron is moving, current is moving in the opposite direction. So have that in mind. With that said, we have established the fact that anode is connected to the positive terminal. And when you connect the anode to the positive terminal, something happens. Electrons would leave because positive terminal will start attracting the electrons which are negative. So electrons leave. But as electrons are leaving, we just established something. And what is that? If an electron is going out, current is going in. So you have that current is moving in the opposite direction. So the anode, we've established something about the anode. First of all, we have mentioned the anode is where oxidation occurs. Secondly, the anode is a positive electrode in an electrolytic cell. It becomes the opposite in a voltaic cell, but we're discussing electrolysis. So in an electrolytic cell, the anode is the positive electrode. And once you have that positive electrode, the anode is also that electrode through which electrons leave the electrolyte. And if electrons are leaving, we said something, current enters. So with all these descriptions and properties put together, we can define the anode as the electrode, or in an electrolytic cell, specifically in an electrolytic cell, the anode is the positive electrode through which electrons leave the electrolyte or current enters the electrolyte. I take it again. The anode in an electrolytic cell is the positive electrode through which electrons leave the electrolyte or current enters the electrolyte. Generally speaking, the anode is where oxidation occurs, but characteristic to the electrolytic cell, it is the positive electrode through which electrons leave and current enters. Quite simple, right? So we go to the next guy, that is the cathode. Now, if the anode is connected to the positive terminal, that means the cathode is connected to the negative terminal. Now, when the cathode is connected to the negative terminal, there is electrons are actually pumped in to the cathode. So you notice that from the negative terminal, the direction of the electrons is into. So that's what makes it negative actually, because electrons are pumped into the cathode. And once you have electrons pumped into the cathode, we said something. If current is going in a particular direction, electrons is going in the opposite direction. So because the electrons are being pumped into the electrolyte through the cathode, current would leave the electrolyte through the cathode. The symbol I is for current. So have this in mind. The cathode is now going to be defined as the negatively charged electrode through which electrons enter the electrolytic cell or current leaves the electrolytic cell. So have this in mind. The cathode is negatively charged. And let me just say this. This is characteristic to electrolysis and the electrolytic cell. The fact that the cathode is negative in this case is characteristic to the electrolytic cell. Okay, when you get to conclusion, we have that in an electrolytic cell, the anode is the positively charged electrode through which electrons leave the electrolyte or current enters, while the cathode is the negatively charged electrode through which electrons enters while current leaves. Remember, these definitions are characteristic to the electrolytic cell. Okay, now having described that, the next term we are going to be discussing as we go further, we have discussed electrolyte. We talked about the electrodes, where we described the anode and the cathode. And what's the next term we are going to be discussing? Quite simple term. Number 3, electrolytic cell. Okay, an electrolytic cell is more or less an assembly of electrons in an electrolyte where electrolysis occurs. So quite simple. Electrolytic cell is an assembly of electrodes where electrolysis occurs. So have that in mind as the electrolytic cell, not too much. And then finally, and not finally, the fourth one we are going to talk about is dissociation. So we're going to be coming across this term quite often, especially as we get into our origin story. So what is dissociation? First of all is this. Electrolytes conduct electricity as a result of movement of ions. If you haven't heard that before, put this down. Electrolytes conduct electricity as a result of movement of ions. So for any electrolyte to conduct electricity, ions have to be in motion. You know, generally when current is produced as a result of movement of charges. So for a metallic conductor or any other conductor, it is by movement of electrons. But for your electrolytes specifically, electrolytes conduct electricity by movement of ions. Okay, why did I have to mention this? If there are no ions, you would find out that there will be no electrolysis. And for ions to be produced, it is produced by a process known as dissociation. So what is dissociation? Dissociation is the splitting of the constituent of an electrolyte into ions. Splitting of the constituent of an electrolyte into ions. Now, note, dissociation process is reversible. That is to say, the ions can come back together if electrolysis does not occur. So, the fact that they are dissociated does not mean that electrolysis has occurred. So, have this in mind. Dissociation is defined as splitting of the constituents of a particular electrolyte into ions. Finally, the last thing we're going to be talking about today is decomposition. What is decomposition? Now, we said that electrolysis is the chemical decomposition of a substance which is brought about by passing electricity through the substance in its liquid state. So, what is decomposition? Decomposition is the breakdown of a compound or electrolyte into its neutral constituents. In the case of dissociation, for instance, let's say I have NaCl solid. If it is dissociation, first of all, it's reversible, and then it is going to be split into constituent ions. Split into constituent ions. This is dissociation. But when you talk about decomposition, it is a breakdown of a particular electrolyte into its neutral constituents. So, for instance, I'm dealing with NaCl and I'm talking about decomposition. First of all, it is not reversible. The decomposition process will lead to production of sodium neutral plus chlorine gas, which in this case is the atomic. So you have that. This is referred to as decomposition because it leads to the production, breakdown of a particular electrolyte into its neutral constituent atoms. This is decomposition. But when you are dealing with a particular splitting into constituent ions, you are talking about dissociation. I hope that with this video you have gotten a general understanding of the introduction to electrolysis. Thank you for watching this video. Remember, this is Wits Learning Made Easy.